Welcome everyone. Today I'm excited to share a novel idea about debugging and finding the root cause of problems within our code. This approach leverages MCP servers and the dynamic nature of languages like Ruby, Python, and JavaScript to create a powerful real-time debugging tool. We will explore how this method can improve our debugging process, making them faster, more efficient, and more insightful. Let's start by acknowledging the challenges we all face. Debugging modern complex applications, particularly in a live production setting, is fraught with difficulties. We often find ourselves sifting through massive log files, trying to piece together the sequence of events that led to an error. Reproducing the exact conditions of a production bug in a different environment can be frustrating exercises. The solution I'm proposing today offers a new way to tackle these challenges. It's a paradigm shift that combines the power of an MCP server with the inherent capability of dynamic code evaluations found in languages like Ruby, Python, JavaScript. This combination allows us to interact with our live application in real time, executing diagnostic code to understand its state at a precise moment we need to. This opens the door for powerful AI-driven debugging, where an intelligent client can autonomously investigate and diagnose problems. Let's break down the architecture of this system. It consists of two primary components. First, we have the MCP server, which in this implementation is a Python server, but it could be just any MCP server implemented in any language. It acts as a secure and controlled gateway, exposing a tool that accepts code for the execution. Second, within our main applications, we have a special controller endpoint. This endpoint is designed to receive the code from the MCP server and execute it within the application's current context using dynamic evaluation. The diagram here illustrates the flow. The AI client sends the Ruby code to the MCP server or any code which is supported by the language itself, which then forwards to the application. The application executes the code and returns the result, which is then passed back to the AI client. Now let's look at this concise example of the MCP server written in Python using the fast MCP framework. This server exposes a tool called evaluate code that can be called by AI clients. The tool takes the code as the input, does the URL encoding of it just to forward it on to the HTTP request, and then forwards it to the application's internal evaluation endpoint using a post request. Fast MCP simplifies the MCP server implementation by providing decorators and automatic tool registration. You can use Fast MCP for quickly spinning up a MCP wrapper on top of your existing application code, but you can use any server architecture as long as you are implementing the MCP protocol. The real magic happens inside the application itself. Here is a generic example of a Ruby on Rails controller that can handle the request from our MCP server. This controller has an execute action that takes the code as a parameter. The most important line here is the binding.eval code. This is what executes the string of the code as if it was typed directly into the console, giving it access to the application's live environment. For other languages, you can use their own dynamic evaluation functions. For example, in JavaScript, you have eval function, which can be used for dynamically executing any string as a code. The result of the evaluation is then rendered as a plain text, or the error is returned to the AI client as an error. So why is this approach so powerful? It provides a level of debugging and root cause analysis of your live application that was previously very difficult to achieve. You can inspect the state of any object, check the value of any variable, and also interact with the application's environment in real time. This creates an immediate feedback loop, allowing you to test hypotheses about a bug instantly. This drastically reduces the mean time to resolutions for issues, and more excitingly, it opens the door for AI-assisted diagnostic, where an AI can intelligently and systematically investigate a problem far faster than a human could ever do. It is crucial to understand that this is fundamentally different from existing MCPs that primarily focus on querying databases. While those are useful for understanding your data, my approach provides insights into the application itself. You are not just looking at the data that has been saved, you are interacting with the live in-memory state of your application. You can execute your application's own code to see how it behaves with real current data. You can even use this to simulate specific events or user actions to see how the system responds. This is a leap from the simple data access to true application introspection and interaction. Of course, an endpoint this powerful requires careful consideration of security. Remote code execution is one of the most dangerous vulnerabilities an application can have. It is absolutely critical that this dynamic evaluation endpoint is never exposed to the public internet. It must be strictly controlled, ideally running on a shadow copy of the production environment with read-only access. We need to have a strong access control policies in place, and we must always be mindful that this tool can be used to change the data and the application state. So it should be used with utmost care. In conclusion, by combining the controlled access of an MCP server with the power of dynamic code evaluation, this is opening up a new and exciting frontier in debugging. This approach empowers developers with a tool for incredibly fast and deep analysis of live systems and doing root cause analysis. And while we have focused on Ruby today, this concept is not limited to one language. You can use any language which supports dynamic evaluations like JavaScript, Python. It can be implemented in any dynamic language, creating a versatile and powerful tool for any development team. Thank you for watching this video.